Convolutional Neural Network (CNN) is a very popular deep learning algorithm for image classification. It typically consists of convolutional layers and max pooling layer for feature extraction, and it uses RELU activation. And after the feature extraction, the final feature will be flattened for normal classifications. There are many resources on the internet explain the theory of CNN, so we will not elaborate here. In this video, we will demonstrate how to perform CNN using Tensorflow on the CIFAR dataset, and we will evaluate the performance of the CNN model and improve the model using the dropout layer. Let's go to the Python code. First, we will import all the necessary libraries, including the Tensorflow. Then we will import the CIFAR dataset, which is the built-in dataset in Tensorflow. We will first explore the data. Let's plot the first training data, and it looks like a little frog. And if we take a look at the shape of the data, it is 32 by 32 by 3. So the length is 32, the height is 32, and 3 means is a colored images, RGB. If we take a look at the training data, it is number 6, and number 6 corresponds to a frog. If we print out the number of classes, there are 10 classes inside this data set. And if we plot out the first 5 images, you can see we have a frog, a truck, and a goat, and a car. Next, we can plot the number of data in each class. This is a training data, and then this is a testing data. And as you can see, it is a pretty balanced data set. Next, we will do some simple data pre-processing. We will first normalize the data by dividing by 255. 255 is the byte size to the power 8, and then we will reshape the data by adding an additional dimension for the batch size. Now if we take a look at the shape of the data, we got 32 by 32 by 3 by 1. Next, we will code the model. So we will import the convolution layers, the max pooling layers, the flattened layer, and the dense layer. The first convolution layer, we use a filter of 64, the kernel size of 3 by 3, a stride of 1, a padding same means that we will keep the same image size before and after the convolution. And we use RELU activation, and for the first layer we have to specify the input shape. After the convolution, we go through the max pooling layer, and then we repeat again with another convolution layer and the max pooling layer. So this part will do the feature extraction. After the feature extraction, we will flatten the final feature vectors and then go through a classification and using the softmax activation. So this is a summary of the model. Next, we will compile the model to compute the loss using categorical cross entropy with added optimizer. And then we run the training for 30 epochs with a batch size of 64. So if we evaluate the model, we got an accuracy about 70%. And if we plot the loss and accuracy, the blue line is is the training data. The training data, the loss reduces with epochs, but you can see that the validation loss is not reducing with the epochs. So this suggests there is some overfitting, where the model fits very well to the training mod data, but it doesn't generalize well to the testing data. Next, we look at the confusion metrics and some of the performance metrics like precision, recall, and F1 score. We use the Scikit-Learn to import the classification report. We get a precision about 0.7, and the recall is also about 0.7, and the F1 is, which is the combined geometric average of this precision and recall, we get about 0.71. Next, we plot the confusion metrics using the Scikit-Plot library. We can see that there are a few cases of serious misclassification. For example, class 3 is misclassified to class 5, and class 5 is misclassified to class 3. In order to solve the overfitting issue, we will now introduce a dropout layer after the max pooling with a dropout rate of 0.25, and then we rerun the model. Everything keep the same. Next, we will evaluate the new model, and now we see that the training loss and the testing loss more or less agree with each other, which means we have eliminated the dropout, the overfitting issue. Next, we look at the performance metrics. We see a slight improvement in the F1 score from 0.71 to 0.74. And if we take a look at the class confusion metrics, we can see that there is a significant reduction of misclassification. Previously, we have about 300 cases of class 5 misclassified to class 3, and that reduced to 100. This concludes the tutorial on CNN. The code can be downloaded below. If you'd like to feedback on the video, we welcome your comments below. And if you like this video, please share and subscribe to our channel. Thank you.